In this video, we're going to look at three applications of geometric series. These are going to be problems you can use in your Calculus 2 course. First, what are geometric series? They are infinite sums of the following form where you add up consecutive powers of some real number r. And this is known to converge to 1 over 1 minus r, provided r is strictly between -1 and 1. It diverges otherwise. So let's look at three problems. The first one is going to be an area problem. And I think this is really nice because it relates to a very common geometric series, which are the where r is equal to 1/2. But all you need to do is draw this line. So this is the line x plus y equals 2 in the xy plane. And then we're going to consider some squares. These are supposed to be squares. And there's infinitely many. The corners all lie on this line x plus y equals 2. We can see on the base of these squares, so the side lengths are decreasing by half each time. So the first side length is 1. The second side length is a half. The third side length is a fourth. The next one is an eighth. And if we add these up, this is infinitely. This is a well-known geometric series. They're just powers of 1/2, right? So by the above formula, if we scroll up, this r equals 1/2 is in this range. So that means this is just 1 over 1 minus a half, which is 1 over 1/2, which is 2. So that is going to be the, and that's sort of clear from this visual picture. The question I would ask the students is then, what is the total area of these boxes, these squares? And again, that should be finite because it lies completely in this triangle, which has finite area. So again, to get the areas of the squares, you would really just square all of these terms. So that the question is, what is the area of the squares? So go ahead and try to figure this out. Okay, so this is going to be the sum of the squares of the terms in the series we just found. And again, each of these terms are smaller than the one we just found, so certainly this converges. Let's write this using our summation notation. So you can write this as the infinite sum. N starts at 0 and goes to infinity, where we will have 2 to the minus n as our side length of the square, and then you want to square that to get the area. Well, using exponential laws, you can move these exponents around. You do that, and the inside is equal to 1/4. So we are really just adding up the geometric series with r equals 1/4. So this is 1 over 1 minus a fourth, which turns out to be 4/3 or 1.3 repeating. And so that is our, I'll use 4/3 here. That's our final answer for this first problem. Okay, I want to give you two more of these. So problem 2. And these are somewhat advanced or a little more interesting geometric series problems. So the next one is find r, and let's say the following: r in the interval of convergence, which will be -1 to 1. Actually, not. Sorry, the open interval -1 to 1, such that r minus r cubed plus r to the 5th minus r to the 7th plus r to the 9th minus r to the 11th and so on is equal to 2/5. So go ahead and pause and try to solve this one. All right. So the key to this problem, or one way to solve this, is to group them. So I'm going to group them in pairs. And I just note that every successive pair is this first pair r minus r cubed term multiplied by a power of r to the fourth. So the solution here would go as follows. The left-hand side, I can just factor out r minus r cubed. There's one of them from the first term. To get the next one, I have to jump by 4 powers of r, so I have to multiply by r to the fourth. And then from here to here, I'm multiplying by r to the eighth, and so on. But that's r to the eighth is just r to the fourth squared, right? So we again have a geometric series hidden in this problem. We can factor the first term as r times r 1 minus r squared, and then this series becomes 1 over 1 minus r to the fourth. Assuming r to the fourth is between -1 and 1, which is equivalently if r is between -1 and 1. So that's the interval of convergence for this series. Now, the next step is to factor this denominator, or this downstairs term, using difference of squares. And then we see 1 minus r squared cancels. So we end up with r over 1 plus r squared. Next, we are going to set this equal to 2/5 and solve. So we cross multiply. We'll get 5r equals 2 plus 2r squared. So 2r squared minus 5r plus 2 equals 0. We can factor this. We need minus 5 in the middle, so we'll get 2r minus 1 times r minus 2. Let me write this r a little bit better. Right, that way we get the minus 5r middle term. Therefore, r is a half, or r is 2. We've already argued that r equals 2 is not in the interval of convergence, so if you plug that in, it diverges, and r equals 1/2 is our answer. You can check, if you plug in r equals 2, you get 2 minus 8 plus 32 minus 128 plus 512, and so on. That is clearly blowing up to plus minus infinity. So it's not going to get r 2/5, but r equals 1/2 works out just fine. All right, the last problem. So in this one, the goal is to find the following. We have 1 plus 1/2 plus a fourth plus an eighth, and so on. The next row will have a third plus a sixth plus a 12th plus a 24th, and so on. The next row is a 9th plus an 18th plus a 36th plus a 72nd, and so on. And then we keep going. So you'd have a 27th, a 54th, and so on. Okay. So what is this equal to? Again, pause and give it a shot. Okay, so the observation here is that each successive row is multiplying the previous row by 1/3. So let's try to write that down and see if that simplifies anything. Okay, so the second row, I'll factor the 1/3 out. And you notice we get, like I said, the first row. The next row would be 1/3 times the previous row, so just 1/9 times the first row. And so on. You can think of this first row as just 1 times itself if you want. Therefore, what we really have is you want to take this expression and factor out the first row from each term, which we obviously see as a geometric series. So this is going to be 1 plus half plus fourth and so on times another geometric series, 1 plus third plus ninth plus 27th and so on. So each of these are geometric series and they each converge. So this first one is 1 over 1 minus half. The next one is 1 over 1 minus third, okay, which is then 2. Next one is times the 3 halves, so we get 3 in the end. So this is just a product of geometric series. All right.